Hello, everybody. Welcome. So we are to session 2 here of day 2 at AWE. My name is Bobby Carlton. I will be here all day long introducing people, talking about the different work that's happening here at AWE, introducing all of our panelists, introducing all of these different sessions that we have coming up. I do want to quickly just thank our sponsors at AWE. So we have Ant Reality, Arbor XR, HoloLight, Lenovo, Sightful, and Zapar are our gold sponsors. And of course, we have Magic Leap, Niantic, Qualcomm, Snap AR, and XReal, who are titanium sponsors. And of course, all of those companies are active. They're in the floor, on the floor. So please go to the expo and check all of that out. So again, let me bring up our next speaker. We have Luis Oscar Ramirez from Mawari. His session is called Beyond the Hype, a look at XR real-world applications and XR scalability challenges. So
here's the click. Okay. Hello, everyone. I'm Luis Ramirez. I'm the founder and CEO of Mawari. Yeah, I'm going to talk about the challenges on how to scale XR. And also, what are the real-world use cases beyond the hype? We're talking a lot right now. We're waiting for next week for Apple to release a headset. Everybody's waiting to be the magical pill that will cure the XR industry. But the reality is that we need to do a lot more to get there. And as a matter of fact, just saw the news from Meta that also released the Quest 3 now, the announcement. So the industry is really catalyzing, and it's going to just grow any further. So let's think about the internet today. You press play on Netflix, and you get a 4K movie on your smartphone within less than a second. So that infrastructure took about 20 years to be built. And currently, the end users actually just take this for granted. So when we talk about the XR cloud of the metaverse in the near future, and like all these marvelous keynotes that we have today, the exhibition booths, we're looking into really, really futuristic use cases. But very few people really wonder, OK, do we really have the infrastructure to support these 24/7, 365 days a year? The short answer is no. There's not enough compute power, and there's not enough storage to power the metaverse as we imagine it all day long. So this is what we call the elephant in the room, that the metaverse cannot be scaled to mobile XR devices. This is for two main reasons that I will discuss. First one is technical bottlenecks. As Ori mentioned in his main keynote, there are a lot of things that need to be fixed still. So technical bottlenecks is one of the bigger barriers. And the second one is the infrastructure supply. As I mentioned, the infrastructure that we have today is not ready for prime time. So let's go into the technical bottlenecks. First of all, 3D content is heavy by nature, as you know, especially if it's not optimized. It's gigabytes or even terabytes of size. And even with 5G connections, it takes a lot of time to download. The second one is the content format. Until today, we've seen 3D content in 2D screens. But when we talk about XR at scale, we need to keep that data in 3D so that we can spread it across networks, across continents, and so on and so forth. So we need a new format. So what is Mawari doing to tackle these technical bottlenecks? First of all, the last one, that it is still a problem. The devices are still overheating, and the battery runs really quickly. But it's much better than before. When we started working in the company in 2017, the AR devices would only last 1 minute. The mobile phones would overheat, and they just stop working. Tracking would be lost. It's gotten much better, but still, we're not there yet. And of course, as we go into a smaller form factor, there will be limited GPU inside the device to process everything. Qualcomm also mentioned that the solution to this is distributed processing. So what is Mawari doing to tackle these bottlenecks? First of all, during the past 5 years, we created what we call the Mawari Engine, which its core technology is a 3D streaming codec. This is a real-time compression algorithm that reduces for example, if you compare it to an uncompressed volumetric video, up to 100x the size of the stream. And secondly, we focus on streaming objects and geometry versus streaming pixels. Why this matters? Well, today, networks are optimized for video streaming. CDNs are built that way. But if we stream the pixel and everything is pre-rendered, if you have the full screen rendered into your headset, you cannot do occlusion and other things that are very important for XR. So how does the Mawari network work? It's very simple. We have an Unreal Engine and Unity SDK for the server side, and then on the client side, developers integrate our SDK, goes to the Mawari network, and the content is rendered in real time to end users. So I will explain the Mawari Engine features. First of all, as I mentioned, we don't do full scene streaming. We focus on streaming objects into your 3D scene. So this is kind of like today injecting a 3D object into your real-time scene. So let's look at this. So since it's an object in your AR scene, you can manipulate the object, scale it, rotate it, do anything you need and interact with it. So as you can see here, we have very low bandwidth consumption, up to 6 megabits per second. And you can see the lighting, the physics of this model is actually streamed from Unreal Engine into this Unity application. Second feature is occlusion support. If we have the depth information of the real environment or the virtual environment, since we are streaming an object, we actually can do real-time occlusion. And it's seamless, as you can see here. Next one is dynamic stream support. So in our vision, as you think today, the websites have like 2D banners, videos, and all this content come from different sources and is hyper dynamic. We see that in the future, 3D applications or XR applications will be the same way. All content will be dynamic, will come from different sources, and will be rendered asynchronously from different sources. So we created this feature, this dynamic stream support. And what it means is that while the application is still running, you can swap and pull content from different servers and be rendered in real time. So in this case, we're going to swap from one metahuman to the other. And seamlessly, you can actually interact with the next human. So our CTO is here, and he can give you demos after this session if you're interested. We just need to look for good signal, because here there's no really good signal. And lastly is split rendering. Split rendering, it is dividing the processing between the device and the cloud. Why this is important? Networks are not perfect. And as much as you have a sustained low latency, there always will be times where the network is not the best, and there will be a screen lock effect. So by rendering the scene locally on the device, you get the best of both worlds. The application is running locally on the device, so you always have this perception of that the application is running. And in parallel, the cloud stream content comes into the application, and you can see it. So we call this as a non-perceived latency versus actually zero latency. So let's go to the example. So you can see here in the example, the grass, these low poly girls are rendered locally, the UI, and then the digital human from Unreal Engine 4, and we're merging it in real time and interacting with the scene. So now let's talk about the infrastructure supply. So, OK, so we have very limited GPU resources in the public cloud. This for many reasons. One of them is right now we have one of the other type of hypes, which is AI. Everybody's using GPUs for AI. But in general, the instances that are available for real-time graphics in the public cloud are actually quite limited. And the big companies and corporations are just in this chicken and the egg situation because there's no killer use case yet so that they can invest billions of dollars and build a full infrastructure again. So our stance is that we shouldn't wait for this to happen. Otherwise, yeah, like all the startups that are here will go bankrupt in less than 5 years. So there's also another very important fact. Last year, we had the Ethereum merge. As if you don't know, it's Ethereum changed from protocol, and now it's proof of stake instead of proof of work. And that means that they don't use GPU mining anymore. So there are a lot of Ethereum miners that went bankrupt, actually, last year, and others that are still operating, but are really looking for new jobs to do, and real-time rendering is one of them. So these GPUs now will be actually repurposed to what they were built for, so for rendering real-time graphics. Oh, okay. So Mawari's instance is, okay, so if Airbnb created the biggest network without actually owning any real estate, and same Uber doing the same without owning any cars, why can't we build the biggest cloud rendering network without actually owning any GPUs? The answer is possible. This is through decentralization. So this is the Mawari network. We are working with operators worldwide, currently in Japan with KDDI, in the US with T-Mobile, and in Spain with Telefonica, in which we are decentralizing and aggregating the compute power, but at the same time, we're also working on the network as a service API so that we can provide quality on demand to each application. So a little bit more about Mawari. We've been called the Akamai of the XR Cloud, the MP3 of AR, the $20 billion codec. So we really hope we can get there. So next, let's talk about the main thing, use cases. So we've been talking about all these use cases, and I will be very honest, most of the XR industry is 40 years old or more. And we are not going to be alive when XR actually is ubiquitous. So we really need to think in the Gen Z and Gen Alpha. What is the content that they will really interact with? And this is, I think, one of the biggest pitfalls, because we're imagining all these use cases as we see the Minority Report, the Ready Player One, but it's unreal. It's not going to happen that way. So what are we doing right now to really try to find that killer use case? And what we have found is two that I will mention. That one is XR Music, and the other is avatar communication. And how Mawari is doing it, we'll present it next. This is our vision of the future. This is the Mawari network over Tokyo. This is completely our metaverse, so please enjoy the video. Are the cloud rendering nodes, and the active nodes are the one actually streaming on location. This is, you are just going clubbing. And then a mixed reality concert at the club. All right, let's go into, okay, so what it will take for XR to really become the 3D XR internet in our vision. Well, from 2017, that's when we started the company. We were working with telcos and all the innovators, really trying to prove that 5G matters for XR. Now we are in the stage that there are a lot more XR developers in the early adopters, but we're still, the Apple headset release is there, but as I say, it's not going to be the magic pill that will push everyone into product market fit. There's a lot more work to be done so that we can jump into product market fit. Mawari has been innovating since 2017 and pushing the envelope, and now our mission is actually to help all XR developers to move across the chasm. So this is, we'll release our Alpha SDK in November. So all developers that are interested, we will help you. We will actually have a community. We'll connect you with enterprises that need use cases, and so on and so forth. So where is the demand for XR today? So the first one is enterprise and industrial. Most of the use cases that you see here today at the AWE are in these verticals. But mainly they are on-premise and location-based. The second one, and the one that Mawari is really focusing on, is in location-based entertainment. There was a little bit of a deep dive because of COVID on location-based VR. But now it's picking up again, and we see the natural evolution into location-based mixed reality. And this is, as I say, Mawari's focus, and also our next focus is direct-to-consumer XR. It's going to happen anywhere, and as we scale the network, it will be available soon. So XR Music. This is a collaboration with a Japanese artist called Yellock. This is an experiment in the Oculus pass-through. Oculus Pro pass-through, and you can see the object streaming, split rendering, music and light synchronization, and motion to avatar. So let's take a look. So point here is that you could be in the streets of Tokyo and Shibuya, or your living room, and synchronously you can watch, or asynchronously you can have the same show. So important to note here, this is pre-recorded, but the main point, and we've seen demand in the avatars be recorded live. So it's a real person controlling the avatar and performing live in the XR metaverse. So as you can see, all this is synchronized between the local scene and the cloud rendered scene. And it really looks like you have the performer in your living room. Then we can be at the street. And a little bit more trippy with the pass-through effects of the Oculus Pro. All right, so then the next one, we call it XRtuber. In Japan, there's such a thing called virtual YouTubers or VTubers. So we're pushing them into XR. This is a project that we did with KDDI, in which actually we capture the facial motion, and we stream it into a cloud rendering server. A digital human, we integrate the voice and the facial data, and then we stream it to the smartphone and real glasses, and then you have a virtual assistant, but that actually is puppeted by a real person. So let's take a look at this. This will be introduced by a digital human.
I would like to introduce you to the latest collaboration between Sturfi and Mawari, in partnership with KDDI and Telefonica. Our goal for this project is to demonstrate the power of XR technologies in creating a sense of co-presence and togetherness, even when individuals are separated by great distances. We will be showcasing this capability in the context of a retail space, showing how the use of 5G technology can enhance and transform the way we interact in shopping environments. Sturfi's digital twin platform enables retailers to create, host, and connect digital twin shops to physical stores. The key element of the Sturfi platform is the Visual Positioning Service, VPS, that connects the digital and physical spaces together and synchronizes user activities across spaces. The platform allows for the creation of a
there
digital
was
twin
a
shop
shop in Tokyo that was a real shop, and then the digital twin in Spain, and both users were joining the shop in real time.
rendering the shopper as a virtual character.
And then
inside
this
the
digital
space,
assistant
while
was
rendering the
remotely
shop
at their
assistant in
home,
AR view with
puppeting
occlusion.
the avatar.
KDDI and Telefonica provide low latency and high-speed network connections, enabling the smooth and seamless transmission of data. In this demonstration, we showed how shop assistants can serve Spanish-speaking shoppers in a store in Ginza, Japan, with assistance from an operator in Spain, while Japanese shoppers are assisted from Tokyo. The Mawari network coordinates the service in both countries, connecting to the appropriate cloud rendering server for the XR Tuber application. Mawari's XR Streaming SDK allows for real-time streaming of the XR Tuber application to both AR and VR devices. Mawari's XR Tuber captures facial motion through a smartphone and voice through a microphone, encodes it, and then streams it to the Digital Humans cloud rendering server where lip syncing, rendering, and streaming processes take place. This provides the shop assistant with the tools to control and animate their avatar and deliver a hyper-realistic 3D digital human avatar with low latency and high fidelity, truly establishing the feeling of being together. Here's a summary of how the system works. Step 1. The operator's smartphone captures face data and sends it to a PC with the XR Tuber application installed. At the same time, the XR Tuber application captures voice from a microphone. Step 2. The XR Tuber app synchronizes voice and face and streams this data together to the digital human application, running on an edge cloud rendering server. Step 3. The digital human app processes the XR Tuber data and streams the result in real-time to AR and VR apps, thanks to Mawari's 3D streaming engine. Step 4. The end-user device receives the stream and sees a digital human speaking naturally with realistic expressions, thanks to the operator's voice and facial gestures captured by the XR Tuber application.
All right, so let's go to the next one, XR exhibitions. So this is a statue hanging from a shopping mall in Tokyo. And we collaborated with the artist called Kohei Nawa. He had a vision that he wanted like a point cloud dancing across this sculpture. And it was very challenging, but the main point is we received a 42 gigabyte file. It's an Alembic file. All the points is about 200,000 points. It has reflections, textures, et cetera, impossible to render in a smartphone. And through our technology, we were able to deliver it in real time to mobile devices. So let's take a look about this project. For this one, we collaborated with Immersal for the visual positioning system. And just as a matter of fact, this was a commercial application. End users would just go to the shopping mall and activate this. It was running for about 14 months in Tokyo, Japan. Now there's another exhibition at a shopping mall, but it was highly successful. And main point is that through any angle of the shopping mall, you could watch this experience, as it is in full 3D and AR. You see some people dancing there. So to sustain this frame rate, only with the power of the cloud. All right, so let's move on. The last use case that I will present today is about sustainable fashion design. Here, the biggest challenge is that a fashion designer wanted to preview this dress in real size without having to actually waste a lot of material. So as you may know, the fashion industry is the second waste producer worldwide. So they have a very strong sustainability goals, and one of them is, okay, so let's do digital design. But it was not enough for the designers, so seeing the actual digital human at real scale in the smart glasses could help this designer to actually make a better decision on whether that was the right design or not. So let's take a look here. This was published on TV in Japan.
こちら服を着た女性が立ってますね。
So as you can see, it's in real time and then real scale, the digital human standing in front of you and checking all the details, high resolution textures, all the physics, so on and so forth. All right, so yes, I think I'm out of time. So if you want to sign up for Alpha SDK, please scan the QR code and we'll talk to you. We are happy to give the demos after this session and answer any questions. Thank you.
Thank you, Luis.